Good evening, everyone, and welcome to our second Wellness Wednesday, where we're going to continue the conversation about wellness and how we can unlock the power within. Tonight, I'm going to be talking about something which we might know a little bit about, but maybe not. I'm going to take a deep dive into unlocking the power of your mitochondria and the NRF1 pathway. So hopefully, I might cover some territory you haven't quite come across. So a little bit about me. If you haven't met me yet, hello. My name is Sharon Kafour and I'm in Melbourne, Victoria. I've been married for 34 years and I have a gorgeous son at university who thankfully is going back to university next week because holidays are finished. I also have a cat that's determined to drive me crazy. I ride a motorcycle and I've been with LifeVantage for 3 years now and I've loved every minute. In my other life, I'm an integrative nutrition health coach. My specialty is helping women understand their bodies as they head into menopause. And my passion is helping women with natural solutions so that they can age with ease and grace or as disgracefully as they want to be. So before we go too much further, this information is only for general information purposes. Under no circumstances will I be making any claims that we can cure, heal, prevent, mitigate, or diagnose any disease. So tonight we're going to talk about the problem with aging. And I don't know about you, but as I'm aging, I'm in my 60s now, there are a few problems, that crop up. We're going to look at the NRF1 pathway and is that a solution? We're going to look at what the experts in the field say. And finally, your options. This is an interesting question. Is declining health something we have to simply accept as part of getting older or not? So if you're here, pop a 1 in the chat box if you think we just have to accept this. What do you think? I don't know about you guys, but I don't accept it. I think, yes, that aging is something that is going to happen. However, we have so much control over how we age. So what happens when we age? I think this diagram shows what we usually expect to happen as we travel through life. When we're young, we're full of energy, we're learning and growing and exploring the world. And then as we get older and we move up through those early years, life changes and we end up going to sometimes university or we move into the workforce. What we don't realize or necessarily think about is that the body typically reaches its peak physical condition in our late 20s. And from then on, the aging process kicks in. Middle age is considered generally to be around 40 to 65 years. And this is when more significant signs of aging tend to show up. It might look like wrinkles and age spots. It might be changes in your hair color, reduced muscle, reduced bone density, and a tendency to have decreased things like vision and hearing. As you get to 65 and older, the risk of age-related diseases such as cardiovascular disease, arthritis, etc., increase as the body's ability to repair and regenerate damaged tissues becomes less efficient. Now, not everyone is going to experience these age-related changes at the same rate. Some people may age more gracefully due to their genetic and healthy lifestyle choices, while others may face more significant challenges. You may have heard the saying that people are living too short and dying too long. Our goal is to help you live a long life, as well as help you have the good health to enjoy your life. So the 3 major theories of aging, as you would have heard last week when Charlotte did her amazing presentation on the oxidative stress theory of aging, which was through the free radical antioxidant imbalance. And we'll be touching a little bit on that again tonight. But what we're going to look at is what happens when your mitochondria don't function as they should. So this is where I kind of went all really geeky. So hopefully I can put it into something that's going to make sense. And anyway, so mitochondria are just so much more than the powerhouse of our cells, although that's what we most often know them as. They make 95% of the energy within the cells that our cells need, and they take nutrients and oxygen and they turn them into ATP. Now, scientists studying them now believe they are actually a kind of stress sensor. They receive different inputs from the cell and then make critical decisions as to how that cell should respond. They play a huge role in deciding whether or not that cell activates pathways to stay alive, keep growing or propagating, or whether that cell needs to initiate programmed cell death or apoptosis. A lot of its ability to respond to different stress signaling pathways has to do with its ability to change shape. Now, sometimes we think mitochondria are kind of like, as you can see there, this sort of fixed shape, but they're not. They're actually almost shape-shifting entities. They can divide, they can fuse together, they can divide parts of themselves that aren't working properly and get rid of them. They're actually really dynamic things. What you also may not know is that mitochondria play a role in some pretty important processes. So cortisol, you may have heard of that, it's our stress hormone. Cortisol can interact and influence your mitochondrial function. So if you think about if you've got really high consistent chronic stress, the amount of cortisol you've got in your body will lead to having an adverse impact on your mitochondria. So whilst it plays a role in the production of cortisol, too much cortisol will turn around and smack it. They also play a role in the health of our brain. And this is where I totally geeked out. Anyway, they're an essential part of overall brain health and cognitive function. And this one may surprise you, but estrogen also plays a role in protecting your mitochondria. And as a hormone health coach, that was really, really interesting for me. So when our estrogen declines during menopause, we most likely have an increase in oxidative stress, which again will come back and impact our mitochondria. Mitochondrial health is also crucial for our skeletal muscles, and they also play a crucial role in gut health. And these are just a few of the many roles that they have within the body. In the process of creating energy for our body, mitochondria naturally produce free radicals, which leads to oxidative stress. Now, when we're young, these free radicals are balanced by our antioxidant defense system. So as we saw last week in that awesome video, our antioxidants are here and our free radicals are up here. And as we age, I think he said when we get to about 30, that ratio changes so that we have much higher levels of free radicals than we do antioxidants. So when our mitochondria aren't functioning efficiently or effectively, the result is a whole host of nasties and downstream effects that play a role in exactly how we age. So what happens if they aren't working properly? So the dangers include things like tiredness. You know, it's kind of like having an energy shortage when your power company goes out and nothing. You've also got decreased physical performance as well, because if you think about it, the mitochondria are giving your cells energy. When do we need a lot of energy? When we're exercising. And they also may impact exactly how your organs function. They also may make an excessive amount of free radicals, which, as you know, leads to oxidative damage. They are crucial in regulating cellular metabolism, so things like glucose and fatty acid metabolism. So if they're not working, that's not going to happen properly. And dysfunctional, I like that word, dysfunctional mitochondria can impact the health of various tissues and organs, which make them more vulnerable to disease and accelerating the aging process. So I'm going to take a little bit of a break here and let you listen to this lovely gentleman from Brock University.
Organelles that are present in cells in your body. And sometimes they have the term the powerhouse of the cell, and that's because of their role in making ATP. When you eat food, your body breaks it down into tiny little individual molecules that make their way into cells and then into mitochondria where they're oxidized. And that oxidation produces ATP that your body uses to drive everything it does, whether moving your arms and legs, or reabsorbing things in your kidney. Mitochondria are thought to be involved in the aging process. A lot of cells in a human body will live the entire adult lifespan. So the neurons that are in your spinal cord, for example, you're not regenerating those and turning them over. Those are with you for life. Over time, that mitochondrial genome can change. Over a lifespan, it can change. It accumulates damage and mutation, and eventually that can lead to the loss of function. As people age, the burden of mutations in mitochondrial DNA does in fact increase. The burden of damage in mitochondrial DNA also increases. Sometimes people who are interested in aging more slowly and solving those types of problems will try to understand more about what is regulating all of this. Because if you can encourage either a diet or could even be some kind of drug that maintains that mitochondrial genome, that population of mitochondria in a unmutated and highly interconnected state, you could probably slow down the rate at which cells decay and degenerate, and that could affect aging. We know of hundreds of different mitochondrial diseases, many of which are associated with premature aging, with fast rates of aging. And one of the things that we are trying to do is to design drugs that we can target to mitochondria to address those problems.
I think he put it perhaps a little bit better than I did. We come to this next question: is NRF1 a solution? Can we restore and regenerate our mitochondria naturally rather than necessarily resorting to drugs? So things we can do to restore and regenerate our mitochondria include things like cleaning up your diet, reducing your sugar, and all the fun stuff like alcohol and caffeine and things like that. Eat food that are packed with vitamins and antioxidants and phytonutrients, whole foods. Move your body in a way that works for you. So I know some beautiful people that are triathletes and marathoners, and awesome. Go do your stuff, people. That doesn't work for me. For me, yoga, walking, doing things like that. Find something that works for you and do it consistently. Good quality sleep, as we know, is imperative for restorative qualities in our body. So get a good sleep routine going. And this one, get some sun on your face every day. Not only does it help with the vitamin D, but also C.4 above. It actually helps with your sleep. And you can give your mitochondria a targeted boost with NRF1. So what is NRF1 and why does it matter? It's a transcription factor, like NRF2 that we heard about last week, that plays a crucial role in regulating the expression of genes involved in cellular defense and protection against oxidative stress. NRF1 can interact with other transcription factors, like NRF2, that coordinates this cellular response to stress and activating a range of genes. That sounds all really good. So how do we do it? This is where Protandim NRF1 Synergizer comes in. So it powers your body to produce more mitochondria and protects the ones that you already have. It increases our cellular energy, which is what we want. It supports mitochondrial biogenesis, which simply is the process by which cells increase the number of mitochondria that you have. And it supports brain function and cognitive performance. Now, our brain is one of our most metabolically active organs in the body, and it relies really heavily on mitochondria for energy and other vital functions. So protecting it from stresses is key. So what's in it? A lot of really yummy natural stuff. So we've got alpha lipoic acid, which functions not only as an antioxidant, but helps regenerate other antioxidants like vitamin C. Coenzyme Q10, which is a vital component of electron transport within the cell, so energy, as well as also being an antioxidant. There's also grapeseed extract, which is a polyphenol, as well as a powerful antioxidant. Quercetin, which is a phytochemical that helps with mitochondrial biogenesis, so that producing of more mitochondria. It also helps to protect the mitochondria. And acetyl L-carnitine, which helps transport fatty acids into the mitochondria for energy production. And it's the synergy of these incredible ingredients that creates the magic. So what are the benefits? Well, I think you can probably guess. It increases our mitochondria. We have better mental and physical performance due to having more ATP. It reduces the risk of dysfunctional mitochondria and the age-related diseases that come with them. And it increases the potential for longevity, which is what we all want, and slower aging. What do the experts say about NRF1? If you haven't come across PubMed, it's a free search engine run by the National Institutes of Health in the US that give you access to a huge range of references and abstracts. So if you go in and type in NRF1 into the search bar, I came across around 2,000 references to it. If you go in and put in oxidative stress or NRF2, there are a gazillion more. Not only that, but our good friend ChatGPT describes NRF1 as a very important factor that helps keep the mitochondria working properly. Protandim NRF1 is produced by a company called LifeVantage. Company is just over 20 years old. We are NASDAQ traded, so we're public about what we do. We make all of our own products. We ship them. We do everything ourselves. Quality is a key focus of the company, and as such, it's very focused on making sure that all of the products are at the highest quality right along the way. Not only that, but we're also approved by the TGA and the FDA, and we have the BSCG certification. Knowing all of that, what are your options? Protandim NRF1 is available in Australia and in New Zealand. It's $86.63 here and $105 in New Zealand. It's a simple matter of 2 capsules a day. I take mine in the morning when I have my NRF2. Now, this is one of our best-selling packs that combines both the NRF2 that you heard about last week that reduces the oxidative stress, as well as the NRF1. Now, I think I mentioned that as we produce the energy in the cell, our mitochondria naturally produce oxidative stress. So think of it kind of like if you've got a pot of water boiling on the stove. So the energy of what's underneath the pot is kind of like the energy that your mitochondria are producing. And the oxidative stress is kind of like the steam that comes off the pot. So putting these two together is a dynamic duo to not only protect your mitochondria and all of your little energy producing, kind of like Energizer bunnies, but also to reduce the oxidative stress. They work in synergy to protect and power up your cellular health. So what more could you want? And finally, that's it for me. I want to really thank you for being here with me tonight. I hope you've learned something. I hope I covered enough that you understand just how important these little guys are. And they are tiny. We've got trillions of them in each of our cells throughout our body. They tend to reside in our big muscles. So things like your heart, your lungs, and as I said, your brain, wherever you need energy. Please share this with your family and friends if you think they could benefit from it. As I said at the beginning, our goal here is to help you live a long life, as well as help you have good health to enjoy along that life. So thank you so much for being on this call. Please go back to the person who invited you and share it with them. Share if you have any questions and if you'd like to order your products. Again, thank you so much, everyone, for being here.